Welcome! In this tutorial I talk about the new fields in Maxon Cinema 4D R20. In this great example by the talented artist Christian Wolf, you see which amazing effects you can now achieve with this incredible new technology. But first, take a look into his final animation. Wow, cool! The scene itself is really complex, but the used technique is due to the new fields and volume features in R20 quite simple. The creatures are built from swept hair and a volume builder measure setup. In the moment of contact of the tentacles with the walls, a vertex map with an infection process is used to build the cool light effect. You will see the work with the vertex maps and the infection process later in this tutorial. But let's first talk about Christian. Christian works as a VFX artist at Pixolution and uses Cinema 4D since ages. He enjoys all kinds of VFX. You'll find more information about Christian on pixolution.de. Before we dive into the tutorial, I wanted to make a brief introduction of myself. My name is Helge Maus and I'm a Maxon certified lead instructor. I work now since 18 years in the industry as a 3D and visual effects trainer for my company PixelTrain. You'll find more information about me and my trainings on pixeltrain.de. So let's get started to dive into the world of fields. And for this I prepared this simple scene here to first understand the principles behind fields. So what are fields? Fields are a great new feature inside of Cinema 4D R20 and offer you as a 3D artist a whole new world of possibilities. For me, it's a little bit like MoGraph 2.0. They replace the old fall-off system in the effectors, but that's not all. But first, try to understand what a fall-off object is and how fields work from this fundamental point of view. So for this, I select here my matrix object and I add here a simple effector, for example here a plane effector. If you want to understand how this effector works, you have to take a look into the effector itself. Here under the tab effector, you have the so-named driver. In a plane effector, there's nothing here because it hasn't got a driver, it only has a multiplier here. But if you have, for example, another effector which has a really obvious driver, for example, random, or I can take here a sound effector, you will see that in the effector here, the driver for a random effector here is a random formula, and here you have turbulence and so on. In the sound effector, we can load here a sound file and we can select here parts of this frequency band to drive the whole effector. The next step an effector normally does is it changes accordingly to this value, which you calculate in the driver, a parameter. So you drive the parameter. And for MoGraph clones, this is position, scale, rotation, but also colors and some stuff more. And then we had a third part. And the third part is also multiplier. And I explain it most of the times in trainings like a 3D mask. And this was the fall-off. That means in the moment all of my clones are moved by this 100 centimeter, or let us take 150 centimeter in the y direction. If you now want to mask this out, we normally go to the fall-offs, and you see that in R20 the old fall-offs now are gone and we have now the new field system here and also a new UI. We have here a fields list and here we have a sub-attributes manager and we have some palettes here to add stuff. So let's get started with the simple new field, and for this we can make a double click here in this empty area and it takes our first field, which is a linear field here. So if you have ever used in R19 a linear fall-off, you see that it looks really the same here. You have this widget, you can change here the length of it, you can rotate, you can move it. But what's different now, and this is one of the big advantages, is that they are now decoupled from the object they mask. What means that you can use them on more than one effector. and you can mix and blend them and much, much more. So if you take now a look here, you see that the field itself is an own object, which is now a child of the plane effector. So if you move the plane effector, this field moves with it. But you don't need to make this parent-child relationship. You can drag it out and place it somewhere else in your scene. And instead of moving now the plane effector, I can move now this field object here in my scene, and you get the change on your clones. You also can add fields by menu. So if you go here to the create menu, there's a whole field create menu here, and you can now, for example, say I want to have another linear field here, and it comes here as a second object. I delete the old one so that I can show you how to assign them. And if you want now to add this field here to the plane effector, you don't make a child of this. You see, nothing happens here. You go into this plane effector here, into the fall off tab, and you drag it here into this list here. And then it works. So the parent-child relationship is only for your convenience if you want to move the effector. But in the new workflow, you don't have to move all the time the effector. You have a separate field object now, which you can move. If you now select the field object itself, you see it has some options here, which we want to talk about, and you also can change here the type of the field if you decide to want to have another type of field. But the nice thing is that you now have, with this field object, the option that you can add the same field object to many effectors, for example. But not only that, you can also add fields to deformers, to selection tags, to weight maps, for example, from MoGraph, to vertex colors, and you can use them in more than one effector at the same time. So it's much, much more flexible. But first, we look now into the basic options here. Our linear field now is back, and if you want to select now this linear field to manipulate it, you can select it here in this list here. And you see, in the moment you do that, all the options of this field here will be presented here in this sub area of my attributes manager. And that's really nice, so I don't have to search for the object here anymore. Also, the widget here is now the widget of this linear field and not the plane effector. So I can move now here this linear field because I've selected it. Let's go through the list. Here's a little tick where you can switch it on and off. That's easy. Then here's a symbol for the field type. You can change the field name if you like. And then you have 2 or sometimes 3 ticks. These ticks or buttons here are what you want to manipulate with the help of the field. This here is the value, and this here is the color. And at this point, I have to make a little side note. Also a new feature inside of Cinema 4D R20 is the color workflow in MoGraph. In R19 and before, it was not so easy for everyone to understand directly how you change colors on clones. In this new version, it's much, much easier, because now if you go here to the effector under the parameters, here is the color mode. You have now a new color mode with the name Fields Color. So you give the whole control about the color also to the fields object. And so these fields here are now changing also the color if you like. So we go back into this here. If you want to switch it on and off, you have now this button here. And then we have blending options. We talk about this in a moment. Let's take a look here into the tabs of a field. First is really easy, it's blending, and these options here are absolutely the same like you find here. So you can enable and disable this here. Also can open this up and change value and color. So these are these 2 options. It's really useful that they are here because you can key them if you need this. Then you have the layer opacity and the blending mode, same like here. Like I've said, it's for keyframing. Then in the next tab, we have the field itself. So we have all the options this field offers. In our linear field, it's really easy. You have the length of the field and also the direction, in which direction the field looks, and you can clip it to the shape itself, sometimes useful. Then we have the whole remapping. Like I've said, a field is like a mask, and you multiply the values, which normally this effector does, by the output of this field list here. And how you want to apply this is done by the remapping. And here's a remapping curve now. If you take a look here and look onto this area here, you see this is exactly the same. If you now want to change here this fall off here, you can go into the strength, for example, and multiply it up and down. Also, you can clip it on the right side if you change the inner offset. The word inner is more obvious if you have a symmetrical fall off. We take an example in a moment. Then we have a clamping for minimum and maximum values, and also you can tell the system, okay, I want to have here a gap, so I start with 20%, or I want to end here with 80% if it's useful. And then we have a contour, an extremely useful thing, because in the moment this curve here, you can't change it here in the widget, because it's changed here by the contour. You have a whole multiplier again for animating, and you have a contour mode. And if you open this up and you select, for example, quadratic, you can have now a curve here. Let me make a little bit more space here on my view. That means if I now go to the curve and bring it here down, you see you get a quadratic curve upwards or downwards. So this is a really nice function. You also have two step modes. One is named steps. You see it steps here. Or you can have a quantize, if you like, also with a step here. And the last option we have is really a curve mode. So if you add this, you see this is your curve, and you can change the curve, how this fall off works. I said that this here is sometimes symmetrical, so let's try something. I remove this field here, so you can select it and press your delete button. And if you now want to have a new field here, you can use one of these buttons here. And the first one here is the fields list. So if you go over this here and hold down, you see it has this little black triangle. So it's a palette behind this. And you see here, these are the field objects. And you see many fields which you know from other versions of Cinema 4D, but also some new ones. And I take here a symmetrical one, for example, a spherical field. I make this field a little bit bigger. And now you see this field here is symmetrical from the midpoint here to the outskirts. And you see here under remapping now that this widget has changed. And now you see what the inner offset here does. It goes here to the midpoint here. And then you can try all the other options again. So if I want to have, for example, now a stepping here, and I want to tell the system, okay, I want to have a whole bunch of steps here, you get something like that. Really cool. And like I've said, if you select your field, you can move it and you get really cool effects. Okay, now we want to talk really briefly about the color. We have changed the values here in this moment. But if I deactivate the values, you also see that we also changed here a little bit the color. Maybe we go back to something more easy to see. If I open this, you see, yeah, we changed the color here to this greenish tint. If you want to change the color now to something nicer, you can go to the color remap. Here you have a color chooser where you can choose the color which you want to add here to the clones. And you see that this remapping here also remaps the color. That's really, really useful. So it fits. But you also can add, instead of a color, a whole gradient. That means that you don't have to live that this red here is always going here to white. You can tell the system, okay, I want to have my own gradient here. And I want to have, for example, red in the outside and, for example, blue at the inside. So it's the same fall off. If you take a look here, if I activate here the values again, but you then get different colors. That's the basic principle behind a field. What happens if we now use more than one field? For this, we have this list. So I have a spherical field and I want also to add another spherical field here. and I place them at different areas of my plane. Now you see that both fields work at the same time. And now you can start of mixing these two fields together. So if you place them now together, you will see that you always get the maximum value of these two. And this is done by the blending. If you have a blending mode of normal, only this here wins, because this here, normal, overlaps this field here. If you want, you also can subtract. So this field subtracts now the other one. You can have an overlay if you like, and also some other modes. Also, you have an opacity here, which is really useful for some effects. And like I've said, you can use now these two fields also on other objects at the same time. You only have to add them into the fall-off list here of the other objects. These are the basics behind this fall-off. Beside of the work with MoGraph, you also can use fields now in the work with deformers. And for this, I've prepared this nice scene here. This is a torus, and this torus is divided with the help of its parameters so that I now can use a deformer. In my case, I want to use a displacer. Let's add it to the torus. And first we have to displace now with the help of the displacer. So go to the shading area. And because I don't have a displacement map, I use a noise here. If we now select something nice, for example, a turbulence, make the global scale a little bit bigger. We can clip it a little bit here to make it more aggressive, and then we can change the height here so that we get something funny here. Like I've said, fields are the replacement for the fall-offs, and our deformers had fall-offs, and so we now can also use the fields in them. Select now our displacer, go to the fall-off, and we see the same list field. And so you can use the same fields which you used before inside of MoGraph. So to add this, we can, for example, now tell the system, okay, I want to use field object, for example, let's take a spherical field here. If we place it now over the surface, you will see that now the field here decides where you want to see here the displacement effect. And this is also useful for modeling purposes, because it's much easier to really limit a displacer or another deformer exactly where you want it. This is a first use. But I want to use now the chance here to show you some of the other objects you can add here to the field list. For this, we throw away the spherical field for a moment, and instead of that, we go here now to the fields layers. What's the difference between these three areas? If you look on the left side, you see the names. Field objects are most of the times objects which are generated automatically by the system. So these are really like the old fall-off things, and they are also a little bit like the old effector objects. So that's the way I think about this. Under this area here are field layers, and these field layers are most of the time added if you drag something from the object manager into the system. If you don't do it like that, you have to show the system what you want to add. But first, we use here a layer which doesn't need anything, and this is, for example, the time layer. This time layer here generates for us an animation. You have here a rate, an offset, and a shape, and you see in the moment you add this, the value which represents is 0, so it doesn't work at all. Better to say it masks out the whole displacer. And if you now press play, you see over the 30 frames now, the mask is gone, and it is now opening the whole thing for us, and you can play here with the rate and the offset. There are also some nice functions here. For example, there's a sine curve if you want to use that. Really useful if you do something like that. Let's throw it away. Then we have here other nice options. Let me take another one. For example, I want to demonstrate you how to work with, let's say, a point object. And like I've said, if you only select the point object now, you see your mouse cursor wants to show an object and I don't have one. So I press the escape key and first do my homework. I add an object. In our case, let's take not a sphere, this time a cube. I place it here and I make it invisible. It's only an helper object. And then we can go into the field list. Now you can use, if you like, the point object again and now show it to the system. That's one way of doing it. And now you see it's added now to the list, and here in the object tab you directly see here this object here, the cube, and you can change it here. Or you can be a little bit lazy. If you have a field list open, drag the object into the list. And now you see it's the same result. But we don't see anything. What's happening? If you now select the cube here and go back to the layer, you see we are in the moment in points mode. And if you see here our cube, you see we only have these 8 points. And around these 8 points, we get a radius of 20 centimeters where the influence is. And it's too low. If you increase that a lot, you see, 1 point is close enough here and another one here. But in my case, I want to use here, for example, surface. This is one idea. And also you have a radius here, you can restrict it. Nice. And you can use the volume, which is also working really nice. And so you can now use your own objects here to tell the system where the field is. And this works for many different kind of objects, from MoGraph objects, particle object, point object, splines, and so on. Let's take, for example, a particle system, only to demonstrate this. I have an emitter here and I place it here in front of that. I want to have many particles. Let's take 50. And we want to have different speeds here. Let's test. Okay, crazy. And I go here to the emitter and open up this angle here, 50 degree. That's it. Okay, not the nicest particle system, but it will work. We now want to use this particle system as a field helper. So go into the system, and this time I drag it. Like I've said, it's for the lazy people. And now you instantly see that every particle has now a radius, and if it comes close here to our surface in the radius of 20 centimeter, we can change this. Now our displacement is shown, and this is so cool. So now you have really fast these cool effects here, and it works really, really well. In this next example, I can show you how to make a morph between objects. For this, I've prepared a sphere here and a platonic object. And we again use our deformers here. For example, this time we use a shrink wrap, which we add to the sphere, and we tell the target object of this deformer that it has to use here the platonic. We can have a subdivision surface over this. And normally we can now animate here the strength, but with the help now of the fields, we can use the whole field system to do that. For example, if you add now here a linear field, and you can move here the linear field over this sphere, you see it now really changed the appearance controlled by this field here. If you want to go into opposite direction, you can use one of the so-named modifier layers. Modifier layers are a little bit like the adjustment layers in other programs. They change what's underneath it. For example, if you want to invert this effect, take an invert here, and if you now take this field and move it over this, you get exactly the opposite direction because you change the values upside down. So this is the invert. But you also can make funny effects here if you, for example, tell the system, okay, I want to start here, and then I want, after 50 frames, go over this. Now we have an animation, and we want now to have a little bit more realistic jiggling and so on. For this, we can go into the stack and use here one of our modifier layers. For example, we have a decay and a delay, and the difference is decay is after the effect, how it goes back into the original state, and delay is really like the delay we had before. So we take a delay here, and I change it to spring mode. And if you now press play, it doesn't happen too much. We see it, but not so much. And the reason for this is sometimes we need values which are bigger than 100%. At the moment, this stack here is limited to 0 to 100%. The reason for this is this icon here. So it's a clamp, and if you deactivate the clamping here, you can really overdo the effect if you like. And now you see how nice this jiggle effect now works. You see, under this area here, you find some really useful options, and you can play with this here to have cool effects. Let's switch to a new topic, and this new topic is working with tags and selections with the help of the fields. For this, we take a new scene, and as an example, I take a simple plane object. This plane is segmented 20 to 20, that's okay. I press the C key and NB for changing here my viewport, and now you see these are my polygons. First, I want to show you how you can work with fields with the help of selections. So I select all of my polygons here, and we generate here a selection tag. And you see now in the selection tag that you now can use the fields in all kind of selections, not only in polygon selections. You also can use fields now in edges, in point selections. You can use it in MoGraph selections, in Vertex Maps, in MoGraph weight maps, vertex colors, and also in Expresso. So you will find fields nearly everywhere. Let's try to do something useful. I want to extrude my plane procedurally. For this, we can use a deformer. So let's take a deformer here, for example, a bevel deformer. I place it under the plane, and normally we get here the edges beveled because the component mode here is on edges. I want to only extrude, so I go here to polygons, and now you see in this tab, polygon extrusion, I can tell here now Cinema how much I want to extrude. To limit that, we normally use the selections, and I have made this selection tag, so drag it into that. And because we have selected all of our polygons, we don't see any change here. And in the classic workflow, we would now go into this selection tag, make a double click here, and then we change here the selection. For example, if I go here and hold down my control key, I deselect that here, then I have to override here my selection, and so on. And so this way is workable, but I want to show you now a more modern way with the help of fields. We have added our polygon selection here, and now I go here onto the selection and say, I want to use the field technology. Tick it. And now we see we get a fields field, and we have a new layer type. It's also a modifier layer here. It's freeze. And freeze is a very flexible layer. It stores values from the frame before, and it can be also used as a simulation. We will see this in the next example. In the moment, the job of freeze is it stores the values which are there from before, so our selection. And now we can add new fields to it. I go here into the fields, and I want to limit, for example, now my selection with a spherical field. In the moment you do that here, you will see that nothing happens. Why? Because freeze has stored the whole selection, and our spherical field here sits on maximum, which means it takes the maximum value. And what we want to do is we want to override everything which is below. So you can go here to normal, that's one way of doing it, or you can deactivate the freeze layer, because here our selection is stored. And in the moment you do that, you now see that our extrusion now is limited by this field here. This is an extremely cool effect, and this is the first step onto a really procedural modeling workflow, which can also be animated, and this is a really great new addition to Cinema 4D's workflow. So let's look into the work with Vertex Maps. I switch into a new scene again, and for this I want to have a little bit more organic shape. So take a torus here, and I want to make a volume out of that. So we go here to the volume builder, drag our torus under the volume builder. We can increase a little bit the voxel size here. Then I need another torus, so I make a duplicate, bring it over. We rotate this here by 90 degrees, and now we can try to merge them a little bit. So we select these two, and we can increase here the pipe a little bit and decrease the radius so that they are overlapping now. Then we can start here to merge them. And for this, we can go into the volume builder. We have union here, that's nice. Over that, we want to have a smooth layer so that it gets smooth. And I want to have here this area a little bit smoother. So if you select the smooth layer here, you have a voxel distance for the Gaussian operation. Make this big. Okay, not too big, I think. Maybe 2 voxel, but you can do it more than one time. So iteration 2. This makes a nice blobby thing. Then we mesh this out again with the volume mesher. And we get a really dense mesh. If you press NB on your keyboard again, you see this mesh here is really dense. And if we want to have a little bit a denser representation, we can go here, make here, for example, a voxel size of 3. That's enough. I want to have many points here on this surface. So select the volume measure and press the C key on your keyboard. Now we have enough points here. What I want to do now is I want to build a vertex map. There are different approaches to do that. One approach would be select here this volume measure, go into points mode, and then we can go here to the select menu, and here you find set vertex weight. You select this, and now you can decide which value you want to store on every vertex. A vertex map is a map in which every point stores a value, and you can change this value between 0 and 100%. So it's a soft selection if you think about this. And I store here the value of 0, which means every point has now the value of 0 and it's represented red in the viewport. This is one way of storing this. Another way of making a vertex map is you select here your mesh, go to the characters menu, and here's a paint tool. Inside of the paint tool, you can decide what you want to paint. You can have vertex maps or vertex colors, RGB plus alpha. In our case, we want to have a vertex map, but keep in mind you can use both. So vertex maps and vertex colors with fields. So in my example, I take this one here, the vertex map, and then you can decide which opacity you want to paint. I want to assign the value of 0 again, so I lower the opacity to 0. The mode is absolute, so I write the values, and then with apply all, I don't need to paint. It's now stored on every point of the mesh. Okay. If you want to now paint something, you can make a double click here on the tag. The first thing you have then is you see it in the viewport, because these values are values which are stored on the points. They are not color in the moment. So if you only select the mesh, you don't see the color at all. But if you select here the vertex map, you see everything is red, and red is the indicator for 0. If you, like I've said, want to paint, make a double click here, so you get the paint tool back. I increase now the opacity, and I change the radius by middle mouse clicking and dragging, and I paint here some 100% areas now onto my mesh. And the 100% is yellow in this color code Cinema 4D uses. If I now want to use this information here with fields, you have to do the same thing like we've done before. Select the tag, and also here in this tag you have use fields. Click this, and here's our freeze layer again, because it has to store the information which we have painted. Now we can take a closer look into the freeze layer itself. It has stored it. You can freeze or clear it, but here are some modes. And if you open up these modes, you have here an extremely useful mode which is named Grow, and this is like a solver in other applications. So in every frame it stores the value again, depending the frame before that. Let's look what I mean. I go to Grow, and I change my timeline a little bit, so I have 300 frames here. I rewind and press play, and you see instantly now the solver works, and my whole object is now filled with yellow, so 100%. If you want to change the speed, you can change here the effect strength. So I go down here to 30%, and it asks the neighborhood points always in this radius here. So if you have a really dense mesh, we can try to lower the radius a little bit. And if we now press play, yeah, we get a nicer effect. If you watched a little bit about infectious systems, which are really popular in the moment, you will see that this is the basic of such an infectious system. And we can use this infectious system for many different approaches. Let's try one. I want to show you how you can change materials with the help of a vertex map, because these are only values in the moment. So add here a PBR material. This is our basic material, which we want to add to the volume measure. And then we dive into the material, and in the material we have a diffuse and a reflection layer. So nothing fancy. I change the value here of the color, for example, to something bluish. Okay, dark blue maybe. That's it. What I want now is I want to see the infection going on. For this, I duplicate now my diffuse layer. You can hold down your control key, make another diffuse, and this time I name this infected. And then I select this, and the infection is, for example, red. That's it. In the moment, they are layered together. Everything is infected, so I now have to mask out this infected layer. And for this, we can use here the mask layer inside of the reflectance channel layer. And instead of changing this here now by this value here, I can use a texture for this. And now comes the cool part. Vertex maps and vertex colors are used inside of the shading system by your own shader. And if you want to use this now, you go here to the shader triangle. Under effects, you find here the vertex map shader. If you dive into this, you can add now a vertex map here, and I drag my vertex map now into this here. And now, because it's placed inside of the mask, you will see that we have here red dots. If you now press play, you will see that now the infection grows over the whole surface. You can use this mask approach. Vertex Maps delivers always the values between 0 and 100 for nearly everything. For example, you can use it for placing hair or whatever, clones. Let's try something. I want to place fur on my volume measure here. So I go to the Simulate menu under the hair objects, and I use fur. And the moment I get everywhere fur. And if I only want to restrict it to the areas which are infected, I can use here the density. And density wants to have a map. So I use the same map here again, driven by fields. And in the moment I press now play, you will see that this fur here is driven by the fields inside of this vertex map. You see how powerful this approach is. So let's finish this here with another example. I remove now the freeze layer because I want to show you how you can also manipulate this here from scratch. For example, I take here a particle system. We have played with particle systems before, and I place a particle system here on top of this, and we make it bigger so that we really get particles on the surface. I make it a little bit bigger, and we want to rain, for example, 60 particles, and we want to stop the emission after, let's say, 20 frames. That's it. So if we now take a look into our tag and press play. Nothing happens. It's only our initial vertex map, and to get rid of these colors here. So let's try again. Go to the paint tool, apply a new fresh vertex map. That's it. Use the fields. Remove the freeze. And now we can override it with an emitter. If we now select the emitter, you see the radius around every particle, it's 20 centimeters. And in the moment the particles now touch the surface, we will see this effect here. You see now that every of these particles here will make a selection. We see this in our material if we like, and then they vanish directly because the particles are gone. If you now want to delay this effect so that the decay here is slower, we can use another of these modifier layers, and this time we want to use the decay so that the vanishing is slower. Add this here to the system. It works on all the layers which are underneath that, and we have here maximum mode, effect strength of 50, and now you will see that you get these drops which are vanishing really slow. We can increase this here much more, and now you have a typical wet map look going on. And this is another example how useful this system can be. So if you now go back here to the system and show the material, and we have to assign our vertex map again under infected, mask here, so that we use this vertex map again. You now see that we now change the material appearance with the help here of a particle system, and you can change here the drops with the help of the fields. If you now want to have this here a little bit more natural, so we can increase that, you can use the next layer here. For example, I take, let's search for it here under the field objects. We have here, for example, a random field, which makes a random formula on everything. We can use here a nice noise, change the noise type if you like to, for example, turbulence. And now we only want to have this noise here where we have values. So for this, I use here a layer mode overlay. And now you see that it looks a little bit more natural, that you don't get these sharp areas here. And then you see the drying. So that's the work with the tags. Like I've said, take a look also in other tags like weight tags and vertex colors and so on. And we make a last example, which is the work with the help of the fields inside of volumes. So let's switch into a new scene, and we build now a volume from scratch. Go to the volume menu, and we take here a volume builder. Normally we drag primitives or polygon objects to the list. Also, you can drag splines and particles and many other objects into the volume builder. But in our case, we want to start with a field. And for this, we have to add a field without having an object on which we can add a field. And for this, we go here to create, and we have a whole menu here for making fields. Here you find the field options and also a group field. And a group field is like a group in other areas of Cinema 4D. So you can add a group here if you like, and the group itself brings a list where you can add your fields if you like. But in my case, I want to show you a separate field. So I go here and say I want to have, for example, a torus field. A torus field alone here looks like that here. You only get the information where the field lies in space, but you don't see anything. And for this, we now take our volume builder and drag the field into the builder. And now you see we get a representation here. This is a volume now, a signed distant field volume. And we can decrease a little bit here the voxel size so that we see it better. What's strange is that it seems a little bit here clamped. And the reason for this is that here the field doesn't know how big it has to be generated, because a field normally is infinite big. So if you want to change the size of the field, you have to select here the field. And we have two creation spaces. One is a box mode, where you can add a box size. Or you can make it dependent on the object itself, which doesn't make sense in the moment because the volume object also doesn't know how big it is and you see nothing in this moment. So we go to a box and then you can increase the box size here and then you get a full torus field here, which works like an object. Nice. But a little bit more interesting is that we can use now this know-how with special fields, for example, like a random field here. If we add now a random field, you see this representation in the viewport where it shows you how this random function works. And if you like, you can go here to the field itself and say the random mode has to be a noise. Then you can select here the noise type. It's a Perlin noise in the moment, or you can use here turbulence, make it bigger and whatever. And if you now want to make this here to a volume, same principles like before, you select the volume builder, drag it into that, and then you have to make sure that the box here is big enough for your taste. So I can change now the size of the box, and now you exactly see that this noise field is also infinite big. You only get a chunk of this. The surface threshold now tells you which value is used for the surface which it generates, and now you can work with this random field here inside the volume like every other volume. So you can smooth it if you like and so on. But I want to show you some important informations about the workflow. So I decrease here the voxel size a little bit more. It takes a while because it's a complex thing. And we want to mesh it out so that you see the end result. So we take a volume measure and drag it here. Now you see that we have really generated a volume here, and we get here these caves, and you can really look through the whole thing. But in some cases, you also will see that some of the stuff is cutted, and the reason for this is that this volume builder here uses in the moment a sine distant field. If you really want to have a full volumetric approach, you can switch it here to fog. And a fog looks different here in the volume builder. You see a fog goes really through the whole space here and fills everything with a volume point here and a value. And so for these kind of works with these fields, fog is really useful. Also, if you want to mesh it, here the voxel range threshold is also really important so that you really can open up the structure a little bit more. And now you see this really cool looking shape here. Like I've said, now you can work with all the other things which are in the volume builder, which I've talked about in a separate tutorial. And this finishes now my tutorial about working with fields. You'll find more useful scenes in your content browser in the broadcast example scenes section. I hope you liked this tutorial. My name is Helge Maus from Pixel Train. Have fun.